Hi, ladies and gentlemen, welcome back. It is Monday, the 28th. It is our asynchronous day, but here's a video that might be a small refresher on what we did Friday, which was about solving absolute value equations algebraically. And we're also going to talk about how to take word problems and build absolute value equations out of them. So if you remember, hopefully you have this in your notes, we solved problems involving absolute values. The way we did it was by following the 4 steps that are listed out for us. Step 1 was to isolate the absolute value. Step 1, we isolate the absolute value expression, meaning get the absolute value expression by itself by using our rules or our, having a brain fart. Our equivalent statements, thank you. Our equivalent statements, which say what we do to one side, we do to the other. We do that until we get the absolute value statement alone. Steps 2 and 3 are kind of combined. Step 2 is you write the 2 cases, case 1, case 2. And step 3 is that you actually solve. So this all is step 3. Not scrolled down far enough, but that's the idea. And again, the way that we set up the cases is the part that is inside of the absolute value gets copied twice as is. The part that is not inside the absolute value also gets copied twice, but one of them gets copied as you see it, and the other one gets copied as a negative version. Don't forget to distribute that negative in, but you should use your solving. Again, what you do to one side, you do to the other. Get all of your x's on one side of the equal sign. Get all of your numbers on the other. Anyhow, once we've done all that, we should end up with 2 solutions. The 2 solutions then bring us to step 4. Step 4 says that we check our solutions by taking our x values that we found and plugging them in to the original equation for x. Once we plug them in, again, we evaluate the original equation, and if we get something is equal to itself, then that must mean it's true. Now, what I didn't go over is this last bit at the bottom, and sorry about that, but it's not terribly difficult. Our 2 answers were 4 and -2 for this problem. So if it asks us to graph on a number line, it's as simple as putting a point at -2, since that's one of our points, and a point at 4, because that's our other point. So I'm sorry I didn't mention that on Friday, but once we find a solution, if we find 2 solutions, we plot 2 points. If we only find 1 good solution, we plot 1 point. And if there are no solutions, well, naturally we can't graph it. There's nothing to graph. All right. Again, you can look through these examples on your course page. They show you step by step how they are solved. You can use them to jog your memory if you're not sure of how to solve absolute value problems. But let's move on to a word problem. Now, in my opinion, it's a little weird to set up these types of word problems because they're easily done in our brains. However, for the sake of argument, for the sake of scoring, I want you to be able to set it up algebraically, even if it is easy to solve. So I'll read through this. The NFL regulates the inflation or air pressure of footballs used during games. It requires that footballs have an air pressure of 13 pounds per square inch, plus or minus 0.5 psi. Again, psi stands for pounds per square inch. What is the greatest and least acceptable air pressures of a regulation NFL football? So there's a certain range of air pressure that the NFL footballs are allowed to be at, They're asking what is the greatest it's allowed to be and what is the minimum it's allowed to be. So in my head, it tells me that I'm allowed plus or minus 0.5. So in my head, I know that my answer is the biggest is 13 plus 0.5, which is 13.5 psi. And the smallest is 13 minus 0.5, which is 12.5 psi. And in and of itself, those are the answers. Again, all I do is read what the problem says, and it's pretty easy to calculate what the minimum and maximum are. However, again, we need to be able to write an equation for this. So here's the idea. We have the air pressure of a ball. We don't know what it is, so I'm going to call that X. X is the air pressure. The value that they're supposed to have is 13. So this is the ideal air pressure. And what this problem is saying is that the absolute, well, not the absolute value, let me not say that, but this pressure is supposed to be the ideal amount, 13. However, the difference between the actual ball and 13 shouldn't be bigger than 0.5, meaning if I took the air pressure and I subtracted 13 from it, the difference, meaning we subtract, that's what difference means, should be 0.5, or the difference is allowed to be negative 0.5. Well, working backwards, these are like my two cases. I take the part that's inside of the absolute value, and I set it equal to the positive and negative version of what's on the other side. So looking at my equation, what's on the left, both of them say x minus 13. On the right side, I see a positive 0.5 and a negative 0.5. Again, those are the opposite values. So if I go backwards, what we're saying is that the part inside of the absolute value should be x minus 13, because again, these parts match. And this part is positive and negative. This part goes on the other side of the equal sign. We normally keep the positive one. And here we have an absolute value equation representing this problem. The air pressure of your ball minus 13, the ideal air pressure, should be a distance. Ideally, it should be 0. Again, remember that absolute value tells you your distance away from 0. If it's 0, that means your ball is exactly 13 psi, and that's a good thing. But at most, they want you to be 0.5 psi away. So that's what this statement is saying. All right, now you have an example. I recommend trying extra example 4. See if you can set up that problem like this, and if you can, you're set to go on setting up word problems into absolute value problems. If you have questions, again today, I have my office hours during 8th period. 8th period starts at 2:25 and it ends at 3:10. Otherwise, make sure that you try the DOL, and then you can start on the homework as well. And if I don't see you then, have a great day.